When the battery is connected to the parallel plates, the electrons will move from the left side to the right side, and both plates, these two plates will have the same amount of charges but different polarities. The left side is plus Q, right side is minus Q. And then we remove this battery. There is the electric potential difference, V. And the capacitance is defined as Q over V. When the charge is increasing, the electric potential difference V is increasing. So this capacitance is constant. It's not changing. Yeah. So V is changing. V is Q, charge Q over C. V is changing with the amount of Q. So the work to move charge Q is Fq dot D. D is the distance between these two plates, and that is QE dot D. ED is the electric potential difference, V. When some charge is moved to the right side, there is a electric potential difference, V. That is Q over C. Then we are going to move little, very, very little Q. And the work to move that delta Q is delta W. Is delta W dot V. V is Q over C. So this is the delta work. So the work needed to move charge Q, charge capital Q, from the left side to the right side is the integral of dq dot Q over C. That is Q squared over 2C, starting from 0 to charge Q. That is 1/2 Q squared over C, or 1/2 CV squared. As Q is CV, or 1/2 QV, as C is Q over V. So this is the work needed to move charge Q. Then the electric field energy stored in the capacitor is the same with WQ. So this is the capacitor with plus Q and minus Q on both plates, on the left plate and the right plate. And the electric field for the left plate is E1 on both on the right side and on this side and this side. The electric field is uniform. So this is E1, E1, and E1. And on the right plate, we have the electric field. On the right plate, the electric field is E2. E2 is on this direction, on the right direction. It's like this. This is E2, this is E2, and this is E2. This is a uniform electric field. So between the plates, the electric field is E1 plus E2. And on the outside, the electric field is 0. And according to Gauss's law, the electric field dot area on the right side and the left side of this plate, that is twice E1 dot A equals Q over epsilon 0. So E1 is this. And also for this plate, E2 is this. So the electric field E naught equals E1 plus E2, that is Q over epsilon naught A. Now we insert the dielectric material, which has a dielectric constant K. Then the electric field equals E naught over K. That is Q over K epsilon naught area. So Q equals K epsilon naught EA. And V equals E dot D. E is uniform electric field. D is distance between the plates. So the energy stored, it's the work needed to move the electrons. So that is 1 over 1/2 QV, and Q is K epsilon naught EA. Dot ED, and that is K over 2 epsilon naught E squared dot AD, area dot distance, that is volume. So the electric field energy density, that is the energy stored divided by volume of the capacitor equals K over 2 epsilon naught E squared. And the unit is joule per cubic meters.